I'm Xuchao from Zhejiang University. So the title of my presentation is Estimation of Anthropogenic Hate in China using points of interest and multi-source remote sensing data. There is growing evidence that the intensity, frequency, and duration of extreme heat events are likely to increase in the future because of global warming. At the same time, China has experienced rapid economic development and a rapid increase of urban population and urban land areas. So this figure shows urban land expansion in Yangtze River Delta in the past. uh, so, as uh, urbanization caused significant increase of urban heat island effect. So there are there are two primary causes of the urban heat islands. First is urban land use, and the second is anthropogenic heat emission from. This is from the industry, from buildings we use air conditions, and from transportation, from the vehicles and the metabolism from our human bodies. So, oh, yes. Uh, each emission is an important parameter in urban climate modeling and urban environmental modeling. But their graded HE data are lacking in most cities across the world. So this is a modeling study. So we model the land use effect and the HE emission effect on the increase of the thermal discomfort hours in Yangtze River data. And urbanization caused an increase of 27% of the increase of the discomfort hours in this region. And the contribution of the H emission effect is almost equal to the land use effect. So in this study, we will using a method to uh, generate a data set of graded HE emission data for China. So there are many methods to uh, estimate the age data. The first one is a top-down method, and others such as energy balance, uh, visual method, and building energy models. This method they need many uh, data and cannot be used. It's difficult to use in the global or regional scale. So in this paper, we use the top-down method to estimate the H emission data. So in past studies, most studies use graded population density data or lifetime life data or land use data to specially distributed the each data from different administrative units to rosters. But removing data and the population data, they cannot effectively capture different socioeconomic activities related to different sources of H emission in urban areas. For example, the industrial areas and commercial centers have similar lifetime light brightness and vegetation cover, resulting in the misdistribution of H flux from factories and commercial buildings. So in this study, we use a kind of geospatial big data. It's point of interest. This data have actually location and short description of its types. So POI data highly related to different human socioeconomic activities. This figure shows POI location from different types in Beijing. So for the factories, they're located in suburban areas. So POI data have the potential to better distinguish areas with high uh, H flux from different heat source, especially in complex cities. So this figure shows nighttime light in Beijing. This is POI density for factories and POI density for buildings. So we can see in the urban center of Beijing, there are low factories. So if we use nighttime light data to uh, estimate the uh, H emission from industrial, there will be cause large errors. So in this study, we first estimated the prefecture level H emission from different sources, from the industrial buildings and the transportation and metabolism. So these are the H emission from the provisional administrative regions for China, and this is for urban levels. For example, this is Beijing. So in most provinces or most cities, industrial contributes last to the H emission. But for the Beijing city, buildings contribute the largest. So this is a flow diagram for the whole study. So for different sources, we uh, build different models from using a qubit machine learning model. We use data from POIs and zone networks, DM, and urban land use data, and the LST, and the lifetime light. We also use population density data. For different PY categories, we use the variable importance as a weight to combine different categories into one PY layer for you for building the source of building and transportation. So this is the result. This figure shows uh, annual mean H emission from industry, buildings, transportation, and metabolism. This shows the total. So we choose some detailed results for Beijing-Tianjin region, and this is Yangtze River data, this is Pearl River data, and this is Chengdu. This is from different sources. We can see, we take a look at the transportation, we can see in the urban centers, the main road uh, have a higher H emission generally. So there is no direct measure of H emission. So we can just compare our results from previous studies. So this our study at 1 kilometer resolution, and this is a study from Dong, same resolution. This is a manner. Uh, Compared with these two studies, we can say that our data have more reasonably spatial distribution. This is the LST distribution. This is the Google Map, Google Earth map. So uh, compared with these previous studies and the LST distribution, we can see that our result is very reasonable. We also analyzed variable importance of, in the qubits model for three sources from industrial buildings and transportations. We can see that for all the three sources, POI related variable have large importance uh, for the HE estimation. So there's a summary. So our method effectively captures the main spatial characteristics of each imaging from different sources and produce a reasonable spatial distribution of each imaging over China. So this new data with high spatial uh, heterogeneity provides valuable input can be used for urban climate and urban environmental modeling. Uh, the last one is there is a great potential for geospatial data, such as POI data, to be used in spatially distributing other socio-economic parameters in the future. Thanks.
Yeah, thank you so much for being on time. Any questions about the Qian? I can hand the microphone over to anyone who has a question. Question, way in the back. Make you run. Let me see if I can reach you. I'm gonna go this way.
I have a very interesting presentation. Thank you very much. This anthropogenic heat means the sensibility drops, or including the latent heat.
Sorry, I didn't get your question.
The anthropogenic heat in your study is means only the sensibility.
Yeah, only sensible. Yeah, yeah, yeah.
Okay.
Mm.
Do you have the estimate of sensitivity to the ratio or the latent heat? Latent heat.
Sorry.
This is the sensitivity.
Yeah, only sensible. Okay.
Thank you for the question. Any other questions? I know that I'm in the back. Maybe looking at some people here. No, nobody has a question. I wonder if you, as you showed us some maps of other studies that have done similar analyses. Have you tried to quantify like how close you are to their results by maybe overlaying the different maps and running some statistics? Or have you thought about maybe doing this in the future to see how close you are to the other results? You showed us the results for different resolutions.
Yes, we just
Yeah, that's fine.
Yeah.
Mhm. Because visually it looks pretty close. I just wonder if you had done some statistical analyses on those.
actually the scale are different. Our results have larger values, especially in the urban centers. For the planar study, you can see the location of urban centers are wrong. I think they are wrong. So I think our results have a more reasonable distribution.
Mhm. Great, thank you.
Thank you.
Well, let's thank the speaker again, and let me pull up the next